Alright, cool. So respiratory quotient. So this is defined as the molar ratio of carbon dioxide produced per unit of oxygen consumed. So it is the carbon dioxide to oxygen ratio. So looking at a combustion reaction of a foodstuff, the carbon dioxide and water is always produced, and then the oxygen is always like on the reactant side with whatever you're talking about. So we get to see that for carbohydrates we've gotten an example of glucose, and then we get to see that when you do up like a balanced reaction, you're going to see that the ratio is going to be a 6 to 6, and it's already going to give you 1. So meaning the respiratory quotient of carbohydrates in general is basically 1. And then for fats, they've gotten an example of palmitic acid, and then they balance it there, and then they do up the ratio, and then overall it's going to give us a 0.71. so that is taken to be the respiratory quotient for all fats, which is going to be 0.71. And then when we look at proteins, so proteins kind of have a variation due to their difference in the composition of their amino acids. So yeah, there's that, but basically all in all, the average value is generally taken to be 0.8 0.8 RQ. So that's respiratory quotient of these guys. So RQ may be used to measure the energy expenditure of an organism. So this method is actually referred to as the indirect calorimetry method, because it does not directly measure the heat evolved by the chemical reaction. Rather, it measures the energy indirectly by looking at the carbon dioxide produced and the oxygen consumed. So it is important to remember that the average kilocalorie yield per liter of oxygen consumed. For fats, it is 4.6. Okay, remember that the respiratory quotient for fats is 0.71. And then for carbohydrates, the kilocalorie yielded per 1 liter of oxygen is 5.11. So that is for carbohydrates, and the RQ is going to be 1. And here we can go on by evaluating that since the difference is small, it may be neglected, and an average of 4.825 is sometimes used if a person does up economics that J. So yeah, that's that. And then looking at the energy expenditure, we said we have the indirect method that measures the oxygen consumed and the carbon dioxide produced, but we also have a direct method which is directly going to measure the heat generated by the Chanchanoko. So next up, we can look at the components of the energy requirements. We're going to see that the total energy by an average person is simply the sum of the 3 energy requiring processes. So we have 1, the basal metabolic rate, and then the 2, the SDA, the specific dynamic action of food, which is just the energy required by a diet-induced thermogenesis. So that is some kind of heat energy released right after a person takes up a meal. And then there is also the requirement for physical activity, because a person is just not always lying down. Okay, even lying down is somehow like a physical activity. So what specific physical activity are they doing? And that is going to help us evaluate the energy requirements of a person. So an extra provision of energy that makes up growth and pregnancy and lactation is always supposed to be kept open depending on the person that is being analyzed. So yeah, so next up we are supposed to see basal metabolic rate, SDA, and physical activity in that order.